Hi there, guys. We're on day 2 of being able to talk about triangle theorems and concepts. I'm pretty excited about this stuff. All right, now normally if we were in school, what I'd do is I would have all of you guys draw yourself a triangle, and I'd hand out protractors and say, all right, everybody measure all the angles, add them all together. And then we throw them all up on the board, and we say, what do we notice? What we hopefully would notice is, wait a second, we all have pretty random, totally different triangles, but they always add up to 180. This is the angle sum theorem. So this is the first theorem that we're learning in this chapter. It says the sum of the measures of the interior angles of a triangle will always, always, always add up to 180 degrees. And while it's cool that I'm introducing you guys to this theorem, you should always demand of me that I prove these things to you. You don't just accept this at face value. So that's what I'm going to do right here with what's called an auxiliary line. So basically, like, I've drawn this line in. It's not related to the triangle, but it's going to help me prove this concept. This is a great example of how geometry always sort of is blending together, and the reason I love teaching this class is that one chapter will flow right into the next. We just were talking about parallel lines and transversals, and that's what we're going to use to prove that there's 180 degrees inside of every triangle, right? I don't think you guys would exactly be calling me crazy when I say that 4 plus 3 plus 5 will equal 180 degrees. I think you'd probably be like, yeah, you know what, Mr. Card, that makes a fair amount of sense. It's a straight line. It's not a linear pair. Somebody in one of my classes called it a linear trio. I don't know that that's a official term, but I like it. All right, this is like a linear trio, okay? And then we're going to use our concepts from chapter 3, like alternate interior angles, to say that if this right here is alternate interior to this, or that this is a pair of alternate interior angles, rather, then 1 needs to be the same as 4. That's true of all alternate interior angles. And then I can use the same logic over here. And so if 4 plus 3 plus 5 is 180, and 1 is the same as 4, and 2 is the same as 5, then hey, I think there's 180 degrees total in here. Now, I'm not going to test you on this proof, but I like doing these for you guys. I like making sure that I can be somebody you trust. And to be somebody that you guys trust, that means I need to prove these things. So here is another theorem that we're going to cover today. It's taking this a little bit further. It's kind of like a converse, okay? The idea that this exterior angle that's hanging out here, so this is another auxiliary line, we sort of just, jut this out here, that's going to be the same as adding those two together, all right? So let's follow a similar kind of proof, which is like if this right here and angle 1 make 180 degrees because they're a linear pair, and I know that these two right here must add together with the blue angle, right? Angle C right here. There's got to be 180 inside the triangle. We just learned that. So if I know that that's the case, that these two, when I add them together with this, will equal 180, then couldn't I also say, and if this also, when I add together with the blue, equals 180, then this by itself is equal to these two together. So here's an example of what that problem would look like, okay? That we have 70 degrees, x degrees, and 2x minus 5 degrees. Because the one thing that they have in common is that if I added them together with this, they'd equal 180. And I know that this and this are equal to each other. That's my setup, then I solve. So this is a short video, you guys. about these angle theorems and triangles. There's a short worksheet that's associated with this, and yeah, I'll pause it there.